150 pound per inch. This is 300 pound per inch.
And that's a straight line.
This is called A. This is called B. Find the actions at A and B. Find the actions at A and B. So this is some load on some beam, and now you need to find the reaction. What we said we should do. We said the best way to deal with it is by dividing it into shapes that I can figure out the areas. Okay? In this situation, how many options you have?
Square and triangle, yeah, I mean,
Square, he says squares and triangle. So here, you can go from here, and you have this side and this side. Other option. So here is a shape, like this, correct? Here is another option, two triangles. And then your book is going to give you, for this one, the lower one, the center is right in here at 1/3 of the base, correct? For this one, the center is in here. Your book gives it to you, and your book is going to give you some, what is in your book says. Go back to the area for two
It's the
triangles
same.
here.
Yeah, but you've got three of the same shaped triangle in there, so it should be the same.
No? This is
So the base times height divided by 2, then?
base times height divided by 2.
Triangle's a
Yeah.
full square, isn't it?
For one, for two of them, or for?
For one of them, for
Oh, yeah, well, it's
this
still,
one,
yeah,
this
so
one
we have
here.
base, yeah, we have
It's-
base times the height, so yeah, base times height divided by 2, yeah.
Is it called Y? Y here.
That's why,
One
area,
third.
area,
Area.
area, yeah, one half base times the height.
Oh, we're splitting it.
You don't have
Don't
to,
give
but
it
you can
area,
see
we
that
are
it's
looking
gonna
for
be the
this
same.
one.
It's gonna be,
This distance
Oh, you're
is,
looking for y, yeah, then it would be, height
what is
divided,
Y?
height divided by 3,
it's gonna be 4 inches.
yeah.
1/3, okay? So, is this clear for you? Either or, let's do this one here. This one here is easy, correct? So, this one is this one. And this one. Agree? Where is the force for this one? In the middle. In the middle at 6 and 6. Agree? What is the force in here? 150 times 12. Correct? The area covered here is, this is 150 times 12 inches. Correct? And in this case, you give the force in pound. Can you see it? 1,800 pound. And this is a pin force or concentrated force, nail force, screw force, whatever you want to call it, pin. It's just like getting there as one arrow. Everybody agrees on this one. This one here is coming in here at distance 1/3 of the 12. Correct? Which is at 4 inches. Agree? The area of this one is going to be half of the 12 times what? 150, not the 300. because we already cut here, this distance here is 150. This one here is 150 pounds per inch. Agree? So times 150. $900?
Yes.
Everybody? Now, I am replacing these.
Which is
In
put
the-
X and Y.
I am not asking you to draw 1, 2, and 3. I am asking you just to make it clear how you draw it. Oh, that's all I want. So here I have a force here of 900 at distance, and here I have another force here of 1800 pound. Dimensions here, this is 4, this is 6 here, this is 9 here, and this is 3 here. The actions, this is a simple one, takes dy only. This is here takes ay, ax. This is a, this is b. Now I replaced the distributed force into a concentrated force. It's easier now to calculate the reactions. Is this clear?
Yes.
Everybody agrees with what we did? Sum of moment at A equals 0. Put your finger here. I have 900 times 4 is negative. 1800 times 6 is negative. By times 9 is positive, equals 0. From here, by equal 400 here.
2700 divided by 9.
How much?
Times 60 times 4.
900, 400. 200, 1200. 1200 plus 400, 1600. Put it in your calculator. Correct?
Yep. You sure?
I'm sure.
Yep.
I'm faster than your calculator.
I disagree, I've got 1200.
Okay, what I did, I took the 9 from here.
Mm-hmm.
900 divided by 9 is 100, times 4 is 400 here. Agree? 18 over 9 is 200, times 2 is 1200.
It's probably done.
Okay, put it in your calculator. Don't trust my way of it.
I got 1,600.
It's also
Correct?
going to be
Yeah.
Okay. Guys, I learned math. I learned math and engineering before they invented the calculators.
I could not imagine a world without a
So
calculator.
these aren't added together. That's
I
why.
totally understand. In the college where I learned the very first class of programming, we used to punish cards with the machine, making holes in them. Put them in a certain order. You have like 1,000 of these cards, certain order. You carry them very careful with a box. I don't want anybody to step on my face because I don't want to drop them. Feed them to machine. The machine used to be a room is this wide, but it's from here like 100 feet long. And it has a machine like the textile machine that you put the whatever the cotton in it and get it from the other side. It starts getting like a robe, then the robe goes into another machine to get it into thinner robes and so on till you get some products at the end. It's 100 feet long machine. You put it from here and it's cut. start taking them one after another. You go at the end there, and the people start coming like this in a row and folding down. After 100, so that's the calculator I used to work. And we were not allowed, till I finished high school, we were not allowed to carry a calculator. High school, not, they will kick you out of the school, not allowed to use a calculator. Anyway, so, 1600, let's go back to sum of forces on Y. Equal 0. On Y I have negative 800, negative 1800 is 27, positive BY, positive AY, equal 0, AY equal 1100.
Yes,
Correct?
yes.
Faster, no? Okay.
Wait, so there's no AX, right? Or you just-
No AX. Sum of forces on X equals 0.
No force.
AX equals 0.
AX equals 0. Let's do another one. Another one. Here is the beam. Good? Or do you want other shapes from your book?
No, we're good.
No, I like
Awesome. What number
Now
is
it's a
this?
sphere.
Is that like some kind of snowdrift or something thing going on there?
200 Newton here, 300 Newton here, and dimensions
300 newtons per meter.
per meter, yeah, 365 Newton per meter Again, find the reaction at A. This is A. Now we are smart. We don't need to draw this picture, this picture, this picture. We will deal with one. It's better if you have a different color to make it easy for yourself. Here, I can replace this one with this force here. This force equal what?
1/2 of 300 newtons per meter times 1 inch.
Correct? Half of 300 times 3. Correct?
And normally it's
The area is 300 times 3, 900 over 2 is 450, correct? Distance here is 1 inch, or 1 meter, correct? Everybody? Let's go to the next one. The next one is this triangle here. I will put a force right in here. This is going to be 600. Agree on 600. 6 times 200 divided by 2. The area of a triangle is 6 times 200 divided by 2. The distance here,
7 inches.
is 2. Agree? 1/3 of 6, which means this total here is 7. Can you see the 7? This one here is going to be right in here. The area is 1000 Newton, agree? 2.5, 2.5. This distance here is 2.5. Agree? 3 plus 6 is 9, plus 2.5 is 11.5, this distance here. On one free body diagram, you don't need to draw three, one after another. What else we need to show on this free body diagram?
Can you say one more time when you find 600 for the middle?
The 600, I'm looking at this triangle from here, this one here. This is the area, is the base is 6, the height is 200, correct? 200 straight to layer, this is 200. Divided by 2, that's the area of this triangle,
Let's draw a reaction at A.
correct? Good. Now, what else I should show on this free body diagram?
Reaction at A.
The reactions. The reactions here, I have AX, I have AY, and I have this moment. Correct? What to start with? Sum of forces on X.
0.
AX equals 0. Agree? What about sum of forces on Y? I have AY is positive, negative 450, negative 600, negative 1000, 2050.